Hello again. We're back after a short break, and I have Hellmar Becke with me today, who has over 25 years of experience in data analytics, and he's going to show us a really cool topic that you can actually experiment with at home if you have a Raspberry Pi or if you were looking for a reason to buy one. Um, so, over to you, Hellmar.
Yeah, thank you, Lena. So, my topic today is let's do data lineage in Kafka, Flink and Druid by tracking aircraft. And well, we'll come to all the aspects of that in a moment. But first, a few words about myself. My name is Hellmar. I'm a sales engineer at Imply. And Imply is the company behind Apache Druid, if you will. Apache Druid is an open source project, more about which later as well. I'm from Germany. I live near Munich with my family. I write blogs more or less regularly, mostly about Apache Druid. And if you are interested in my blog, the QR code here takes you directly there. So, data governance is an enterprisey subject, and my goal today is to bring it a little bit down to earth and to make you able to experience it at home with things that everybody has at home. So we're talking about data governance and specifically about streaming data governance. And then we are going to put together some parts of what we are going to need. So I'm going to talk a little bit about Kafka and Kafka headers. I'm going to talk about Flink and streaming ETL and Kafka headers in Flink. I'm going to talk about Apache Druid because what we want to do in the end is streaming analytics. And for that, we are going to use Apache Druid. For Kafka, Flink, and Druid, they are all open source tools that you can easily use at home. We also need a data source or data sources. And for that, this is where the Raspberry Pi comes into play. So these are the components of our end-to-end data processing chain in which we want to track data lineage. And I'm going to put this all together. And hopefully, if the demo gods are with me today, I'm going to show a live demo about all these things. So data governance. I shamelessly plagiarized this from a blog that was on the Confluent website, I think. It's a collection of standards, processes, rules, and metrics that ensure that data is usable, accessible, and effective. Sounds great, right? So it's about, first of all, it's about data quality. Second, it's about data discoverability, which means you need to have a data catalog. You need to be able to find your data. And the third is data lineage, which is end-to-end tracking of where your data comes from, how it has been handled, how it has been processed. And all this nowadays, in a world where we're talking about streaming data, event data, not batch anymore, we also need to put a streaming aspect to all these things. So it's stream quality, stream catalog, and stream lineage. There are great blogs about the first two aspects. Stream lineage is also something that tools exist about, but like I said, I'm going to talk a little bit about lineage and how to track where your data is coming from. So let's do this with respect to really practical data. How are you going to track lineage in data? Well, basically what you do is you attach metadata to your data. And because we are doing streaming data, we have to attach metadata to every single data record. The standard streaming platform that most everybody uses, or actually, no, let's put it another way. The standard for streaming APIs nowadays is more or less Apache Kafka. So if you're talking about data streaming, you have either Kafka or something Kafka compatible, such as Red Panda, or you have something that is working in a different way, but usually exposes a compatibility layer. That might be the case for Apache Pulsar or for Microsoft Azure Event Hubs, where you have a Kafka layer as well. So Kafka is pretty much the standard. In Kafka, you have got messages that are records, and the records have a key and a value. Everybody knows about that. It also has a timestamp, which also most people know about. A lesser known feature is that you can add any kind of headers to your data. Kafka headers are key value pairs, where the key is a string and the header is not even a string. The header is basically just a byte array. So Kafka does not really put a lot of internal intelligence into interpreting these things. So you can read these header pairs. You can add header pairs to each record. And if you process data with the chain that we are going to use today, then you can also pass them through these through these stages. So in Kafka, you have headers, key and value pairs. In Flink, you would introduce these to your table schema. You add these as metadata columns to your table schema. It would be a map of bytes to bytes. And if you really want to do some processing with on top of these data in Flink, you have to decode your bytes. So you have to use decode and encode functions. You can do that. Now, the nice thing is that with Druid, Druid is an analytical database, and I'll come to that in a moment. Druid can read Kafka record headers natively. So if you have all these pieces together, then Kafka headers give you a wonderful way of attaching envelope information, if you will, so data lineage information. Where has your data gone along all across your processing chain? So what we are going to do here, and I'm really showing a very, very simple example. You can do a lot more. In Flink, you can process your data, and I'm going to show this with the Flink SQL API. And in that, you put a table on top of a Kafka stream in a way that you have, like in this example here. And this is actually the example that we are going to use. So you connect to a Kafka stream, specifying the Kafka connector and your format stuff. And then you have got your Kafka headers mapped from bytes to bytes. It's a metadata file, the metadata field. Where we are going to land all those data is in Apache Druid. Now, Apache Druid is a streaming analytics database. If you want to see what is happening in whatever system that you are looking at, you are putting analytics to the end. The classical analytical thing, and I've done a talk about that at the Big Data Europe last year, is how we used to do things is in batch. Yeah, you have operational databases, you have a batch process that then transforms and loads those data to a analytical database, and then you have put your business intelligence client on top of it so that you can show your graphs and charts and maps and what have you. In the streaming world, you have a similar challenge, but you want to do it all live. So you want to have sub-second queries that give you your results immediately, and you want to have results on top of data that is streaming into your database. So basically, you want to have a picture, you want to have a flat snapshot of what is in your stream at any given time, so that you can slice and dice your data, you can analyze your data every which way. And that is what has been realized, what has been implemented using Apache Druid. Apache Druid is a distributed database that is built for streaming analytics. And what you see here is a vastly simplified model of how Apache Druid works. It is a distributed architecture, shared nothing, microservices based, if you will, and you've got various processes here that have various functions. We've got to the right, we've got so-called master processes that deal with data discovery, service discovery, process coordination, cluster state, all that. Then you've got query servers that run query brokers, so they are client-facing. And then you've got data servers that do the heavy loading. You've also got an archive storage called deep storage, which would be mostly cloud storage or something cloud storage compatible, or it could be HDFS, something like that. So what happens when data streams into this system? Data is already handled in a parallel way. So to the left here, this arrow, this might be your Kafka stream. It has n partitions. You could have n so-called indexer processes that listens each to one partition of data and collects Kafka messages, analyzes these messages, and transforms the messages into a columnar format, which is called the Druid segment format. The Druid segment format is partitioned by time, sorted by time, columnarized, fully indexed. And the indexes that are automatically created are compressed and sorted bitmap indexes. So this is a really cool thing because, well, first of all, bitmap indexes means you can have the indexes local to each segment. Each segment can be packaged with its own segment. Secondly, it is super fast for point lookups. Thirdly, because the index is sorted, it's also super fast for range lookups. And fourth, it is super fast for combined filters, because combining two bitmap indexes is basically just a bitwise Boolean operation. So very, very optimized. These segments are built up in memory, and once the segment has reached its target size, it is handed over to the deep storage and then brought back to the historical process. These are also distributed, and segments are replicated on the cluster so that there's always more than one. So the result of this data ingestion operation is that we've got ready-made, fully columnarized segments that are accessible by the historical processes in local storage here. And we've got those segments that are still under construction by the indexers, and they are held by the indexers in memory. Now, if a query is run against this system, the query broker accepts this query. And again, like the data servers, also the query servers can scale. The query broker analyzes the query, creates partial queries. After looking at the query, it finds out which segments to interrogate. It asks the master services where to find those segments, and then sends partial queries to all those services, retrieves the results, and then assembles the final result, applies aggregations, applies final filtering, ordering operations, and so on, returns the result. So this is the secret, how this is all very fast and very flexible. And this is how you can query a stream. And the interesting thing here is, sometimes people would ask me, what is the difference now between Flink and Druid? Because Flink can also do SQL on streams, right? Now, what you want to do here is Flink is a great tool to transform one stream or a set of streams into another stream. Druid is the final landing point. And if you put Kafka, Flink, and Druid together, you can create a great streaming architecture that looks like this. So you would have all your data sources that are here on the left. And usually, if you build an enterprise architecture, then you would have all kinds of databases and files and streams and what have you that you could collect into Kafka as a central nervous system. You would use Flink as the processing, streaming ETL, and then you would land your data in Druid. And that is what you want to do for any kind of streaming analytics architecture that you would build, be it big, be it small. And if you do this for a big company, then some enterprise architect will say, okay, this has to be auditable, and that is why we need data lineage. And that is how I came towards the subject of this talk. Now, what kind of data are we collecting here? Well, the internet is full of it. It is very, very easy to collect aircraft radar data with the Raspberry Pi. Commercial aircraft, and in fact, most aircraft that are flying around are constantly sending data about their whereabouts, their identification and such on a frequency 1090 megahertz. And these data can be freely received by anybody who has a tuner that can listen to this frequency. And long ago, some smart people have found out that a cheaply available digital TV stick that contains a software-defined radio chip can easily receive these data. And there's a free software, dump 1090, that you can download, install on the Raspberry Pi, and then collect these data and look at your aircraft on a map. And there are commercial portals, as you know, probably, like Flight Radar and what have you, that allow you to watch all the data that is collected by many of these stations on a global map, and look at the aircraft and the identifications and all these things. Now, what I've done is I've talked to some of my friends and colleagues, and I've said, how about we start as a proof of concept? We've tried to figure out how to collect data from multiple points and get it all sorted out. And that's what I've done here. So I have taken a Raspberry Pi with a TV stick, and I've installed the dump 1090 open source software, and then I've created a little script that the open source software exposes its data as a kind of CSV-like format on port 30,003. And there I collect these data and I put them into Kafka-Cat or KCAT in order to send these data to Kafka. So I say, please send these data to this topic, this Bootstrap server, which is in this case here, well, because I just have this available. It is a Cloud Kafka service. So, and what I'm doing here is I'm adding these headers. And that is what you can do very, very easily with Kafka-Cat. So I'm adding a header for the client ID. So each of my friends and colleagues that is running such an Raspberry Pi, I've asked them to put in a unique identifier as the client ID. I'm also putting in the client time zone, and I'm putting in the geographical position of the receiver of the antenna. And so all this data is then collected into one single Kafka topic, and this is how I get my data. So we've got all the components now, right? We've got, at the beginning of the chain, we've got these Raspberry Pis that are collecting aircraft transponder data, and I've got some folks that are doing that in the UK and others in Germany. We are sending these data to Kafka, to a Kafka service in the cloud, and from there on, I'm going to continue with a demo that I'm running in Docker on my own laptop. And this demo is running a local Kafka so that I can transform my data and then put them not back into the cloud, but looking at those data in my local Kafka. I've got Flink there, and I've got Druid there. And I hope I will be able to show how to land those data in Druid and how to track the lineage of those data and reproduce this lineage inside Druid. So let's go and start and see if the demo works. So here is my Flink SQL. This is, well, like I said, it's in a Docker Compose file. The query that I'm running looks pretty much like this, but I'm pulling my data out of the Cloud Kafka stream. So I'm not going to copy paste the exact query here because it has secret credentials. The trick here is that in the first step, and my data is actually at this point pretty raw. I said before it is a CSV-like format, but actually the way this format is defined is such that the number of fields is not constant. Now, Flink has various ways of interpreting incoming data. One would be CSV, but it will choke if the number of fields that it expects does not match the number of fields that it finds. So I cannot go this path. What I'm doing instead is I'm using a raw value format, which means that I have as the payload from the Kafka message value, I've got only one field that I can view as a string. This is the val field here. Then I need to have my Kafka metadata fields, and these are 3 in this case. So I'm going to get the Kafka timestamp. I'm going to get the Kafka headers, which are the ones that are tracking my lineage, and I'm also going to get the Kafka key. So I need to define the key fields prefix here in order to distinguish those fields from the ones that are in the value. So it's a bit tricky to get this right, but in the end, once you figure it out, it's not that bad. So I have done this. I've prepared this already a little bit, like a good TV cook, so that I can now do something like this here. I do a select star from this table ADSB raw. So this is supposed to have only a value field, and I hope it has some data now. It can take a moment. There. And you see here what is going on. We've got the Kafka timestamp, which is interpreted here. So this is some date and time. I've got the Kafka headers. And like I said, the Kafka headers are interpreted just as bytes. And this is what is reflected here in this view. I've got the Kafka key, which is the aircraft ID. And I've got the value, which is my CSV-like data record that is coming from the dump 1090 software. So this is pretty good. This is what I wanted. Now, in order to be able to put these data into an analytical engine, I need to impose some schema on this. And for the purposes of this talk, I'm doing a simplified way of doing this. I create another table, which is going to also be associated with a Kafka topic, but this is on my local Kafka, which is this one here in my Docker image. And I need to do a few things here as well. I'm passing through the lineage information here with the Kafka headers. So I'm also passing through my Kafka key and my Kafka timestamp, and then I define all the fields that I have in my message, like they are defined. And I need to give a topic name. So this table is backed by a Kafka topic, so I need to give a topic name and various other options that are listed down here. And this defines my table. And then it's time to put some data in. And for that, I take my data from my table that I had previously, from the unstructured table. And now I'm doing some pretty pedestrian work where I collect each field by applying a split index function. So I split my payload string by the comma separator and pick then field number 0, 1, 2, 3, and so on and so on and so on. The nice thing about that is that if a field doesn't exist, the split index function will just give me a null value. So this is safe. So this is a safe way of populating the data inside my new table. This table is also, and did I mention it before, it has a value format of JSON, so it will have JSON data. Now let's look what this does. Oh, it does something. Why is it now not working? think yeah, that happens sometimes. Yeah, there it is. So now this is now inserting my data, and I think I should be able to see this job now here. Exactly. I see this job now running in the Flink console as well. And now I have a table that is in JSON format, which is backed by a Kafka topic. And let's look at how this looks in practice. So what I'm going to do is I'm going to select all data from ADSB JSON. And now you can see it. Now we have the structure. We've got the Kafka metadata as before, but we've also got the message type, transmission type, and all the things that are now that don't fit on the screen anymore. This is data interpreted by Flink. Now let's do let's look at the same data in Kafka, and here you can see how the data that were before in the CSV format are now in a JSON format. Now it's time from here to go to and look at the how to analyze these data. So I go to the Druid console. So Druid, my analytical database. In order to connect to a stream and analyze the data in the stream, there is a easy to use wizard where I say I want to connect to Kafka, and I need to tell Druid where to find that Kafka. Voila, typo. Kafka 1992. Topic ADSB JSON. And here you can already see what is happening. We've got each record here listed like this. This is a preview. The payload is the JSON that we saw before, but it also picks up all the header fields. And here, this is my colleague Hugh. He is on British Standard Times, and this is where he's located. And now we'll just go through the wizard. The first thing is specifying the payload format. It has recognized this as JSON, so this is all good so far. We've already got the Kafka metadata fields in here as well. So I think here is the client ID again. Next, we pick up the timestamp, because I told you before that it's all time-based, so you would have a timestamp in your data model. You can apply transformations here, but we're not going to do that. And this is my data schema, so now I'm already good to go. I need to define the segment size here, and I want to read from the beginning of the stream. And I give my table a name, which is ATSP JSON, and I hit submit. And that's all that there is to it. And why is this now not working? The demo gods are really not with me today. I think another process crashed. Okay, one moment. Yeah, now we are good again. And it's running actually. So here we can see that the process has started despite the little hiccup. We should have some data in here as well, and we can query those data. So let's do something like, here's my data. And you can see it has picked up all the fields. We've got the receiver latitude, the client time zone, receiver longitude, and here the client ID. Do a select star, it's all there. And what I wanted to do now is this one here. So now let's see if we can track the data lineage, because that was, remember, that was the whole idea about what we wanted to do. We have the data, that is easy, and I've done this before. But now I want, this is now called ADSP JSON. Now I want to see where my data came from. Okay, so here's the data collected by my receiver. This is collected by Hugh. This is collected by Peter. And this is what we wanted to have. Actually, I can also do some little things here, like this is also built in. Chart over time. Now let's break this down by, oh, this is the wrong table. Need to do this one here. Break this down by client ID. And there you go. Here you can see it. And this is just counting the number of records. And just like this, we've been able to track data back to its source without actually altering the data record. So this was the whole idea. We've added metadata, we've passed these metadata through Flink, and of course, this is only the beginning of the story. And in a limited time talk, this is what you can do. But in a more complicated setup, you would then do things in Flink, like you would apply your time windowing, you would join other data sources, you would put everything on a nice map and all these things. But that is another story for another time. So for now, I would like to conclude with a few final remarks. Data governance, you will hear this a lot whenever you talk to people in an enterprise context, if you will. I've worked in a bank some years ago, and their Lineage was a big thing. Lineage is a crucial part of data governance, and the way we can track Lineage is by adding metadata to each data record. For Kafka, which is the most popular streaming data platform, one way to do this is using Kafka record headers. And if you build an analytical stack out of Kafka, Flink, and Druid, then you can track data lineage end-to-end with Kafka headers. And with the built-in capabilities of Flink and Druid, it's actually easy to do. So I think the main learning from this is, don't be scared of enterprisey things. It comes down to very, very basic concepts, and these basic concepts you can try at home with public data sources, with publicly available free software, in order to teach yourself the basic concepts. There is a few, I think we will later share the slides. There are a few, here are a few sources that I used in order to compose this talk. You will find some of the code in my public GitHub repo. And with that, I say thank you, and we've got some room for questions.
Thank you for the lovely session, Hellmar. It was very exciting to see actual aircraft data being used for this demo. So I can't help but ask, if this was if this was Apache Pulsar instead of Kafka, would you still be able to get the same results? Because we had the session earlier about Apache Pulsar being potentially finally a good replacement to Kafka. So, would it be a good replacement in this scenario?
Lina, that's a great question. um, uh, I have kind of, well, first of all, it would definitely work. And the reason it works is because Pulsar has, like I mentioned before, there is a compatibility layer, which is called Kafka on Pulsar, or KOP. And that enables you to use Druid with Pulsar. I believe there's also a Pulsar integration with Flink, although I'm not so sure about that. I suppose it has been done. Otherwise, you could also use the Kafka compatibility layer. So that is the answer within this context.
Okay. And
Now,
outside of this context, what's your personal preference? Because technology choices are like religious choices. Everyone is very polarized into using one type of technology.
yeah, and I admit that having worked with Confluent for 2 years in my career, I'm a bit of a Confluent and Kafka fanboy. But I have to say, Pulsar is a great product. Pulsar brought in some components, or like some concepts that were missing from the original Kafka, like storage tiering, like separation of compute and storage, having multiple namespaces in one cluster, all these things. Interestingly, the folks at Confluent have copied some of these concepts into Kafka, some of which have gone into open source Kafka, and others are only available in their commercial offering. But I mean, I don't want to make this a sales talk. So, like you said, Lina, it is a bit of a religious choice. And I think Kafka and Pulsar are both great products, and they are both fit for this purpose.
Okay. And the solution you showed today, what would be the challenges of operating that? So if we go outside of the demo and you implement this infrastructure and this combination of tools to get the data lineage, what would be the operational challenges?
Well, first of all, I mean, obviously you have to operate some clusters, right?
Yeah.
Yeah, you have to operate a Flink cluster, you have to operate a Kafka cluster, you have to operate a Druid cluster, and you have to put all these things together. You would also typically not produce your edge data into Kafka, which is what I've done here. So an end-to-end architecture would often more be something collecting data from the edge, from sensors, from IoT devices, what have you, sending data through a protocol like MQTT, having another gateway that is between the edge world and your data center world, and then then like I said, you've got basically you have to manage 3 distributed systems, which is why a lot of people that I talk to nowadays prefer to use managed cloud services. But of course, that is something that goes beyond trying out things at home, because that is usually associated with some
Yeah.
cost.
Yeah. Well, again, CapEx versus OpEx.
Yeah.
Um, whether you want to pay for the managed service or go at it alone, and it depends on the size of the organization as well. And do you
It
think
depends.
that or yeah.
Yeah. I was just saying it depends on the size of the organization. It depends on the will of people. It's like I mean I've talked to a lot of companies where sometimes you have those companies that say I want to be able to scale my organization. I want to I don't want to rely on a handful of specialists that have the knowledge. Where you have a bus problem, like if one of my specialists gets run over by a bus, then the knowledge is missing. And then I've seen other companies that say, I don't want to rely on a cloud vendor that may at some point change their terms of service, so I build the knowledge in-house. It's a philosophical question, isn't it?
That's exactly the kind of discussion that I've been in recently, specifically around the cloud, because it was like, but before we migrated to the cloud, everything was so easy because we were autonomous and we knew how to operate it, and now we don't know how to operate it, and we have to rely on other people. But at the same time, to me, it's like you can't be a specialist in everything, and you have to at some point focus on what you need to develop as an organization and let go of some of the things and maybe have a plan B for vendors.
Yeah,
I don't know,
absolutely. Mhm.
but again, it's personal preference as much as anything else. And do you think that organizations are focusing more on data lineage and data governance these days?
The big ones, absolutely. Yeah.
Or is it,
So
yeah, but the smaller ones, it's still not that big of an issue. I think data governance is predominantly something you hear in larger organizations.
it is. Yeah, it is. And uh, the point where I got first confronted with this was when I worked in ING Bank some years ago, and their chief architect was doing really a lot of work, talk, evangelization about data governance, metadata management, and such things. And he was really hammering it in, um, do data lineage. And then I noticed that, well, like I said, in smaller organizations, many people don't even know what, what what I'm talking about when I talk about data lineage. So I also wanted to make this concept a bit more digestible.
Yeah, yeah. I get that absolutely because yeah, we have to figure out a way for smaller companies to understand what bigger customer companies are going through without just stop with the bureaucracy and
Yeah.
unnecessary complications.
And in the end, it boils down to relatively simple concepts. And if you look at, the presentation of your chief enterprise architect, which is like a big slide full of boxes and arrows where you easily lose track what is the central message, then it might be intimidating for some.
Yeah, but I think it's going to become an even more important topic for IoT companies that also have machine learning for their
Yes.
IoT devices. Because otherwise it's going to become impossible to track like what information was used to train your model, where did everything come from, or
Yes, and that is why I think that these concepts will become more widespread, and that even smaller organizations will have to apply some data governance concepts in the future.
yeah, I think you're right as well. Well, thank you very much for the very informative session. It was very fun to look at a live demo quite as interesting as yours. And we're going to go into a small break and then the last keynote of the day.
Thank you.
Bye.